So one really common use for the polar plane is to talk about complex numbers. The reason why is there's a lot of symmetry in the complex plane, and symmetry is difficult to discuss in the rectangular plane. However, in the polar plane, symmetry can be discussed using angles. It's easy to talk about three-way or five-way or eight-way symmetry when what you're really just saying is, oh, 45 degrees, 120 degrees, whatever it is. So we're going to take a look at complex numbers, which we've seen before. Keep in mind, complex numbers in the past have been this a plus bi business, where a is our real part, and that bi is our imaginary part. So when we're taking a look at that I is the square root of -1. That came back, that would have been the quadratics unit back in first semester when we were playing around with quadratic formula or possibly completing the square. So you can graph things in that a plus bi form by just letting that real part be your x-axis and that y part be your imaginary axis. Notice the coordinate planes we're looking at here have an R there as well as an I. You're looking at other resources online, perhaps Slater, possibly like a Stack Exchange. A fancy name for this is the Argon plane. I won't use that terminology, but in case you see it somewhere else, you're not freaking out by the new vocab. So we're going to graph some complex numbers here. -5, we're going to graph that on the real axis, the one that I have highlighted in blue, and then the 2i, we're going to graph that on the imaginary axis. And it really is just middle school graphing. I'm going to count to the left 5, 1, 2, 3, 4, 5, and up 2. 1, 2, there's my point. Yes, really, that's it. So graphing that complex number on a rectangular coordinate plane looks like that. We can do the same thing here for number 2. 1 to the right, 4 down, and I get a dot right there. Taking a look at the very last example then, note that there is no real part to number 3. I just get the 3i, so I'm not moving left or right at all. I'm just going up 3. So hopefully this part isn't too crazy. You can think about graphing your complex numbers in that a plus bi form the same way you graph an xy coordinate pair. We can also go the other direction. If you have some point in space, you can figure out pretty quickly using rectangular coordinates what that point is. Notice, let's break it up into reds and blues this time. I have 4 units to the right, so that's represented as a +4. And then I also have 3 units up, which we represent as a +3. But keep in mind, this is the complex plane, not just your regular xy plane. So as a complex number, that would be 4 plus 3i. Number 5, very similar. Now we're counting to the right, 1, 2, 3, 4, 5. But going down 1. So as a complex number, that would be 5 minus 1. Yeah, the colors are fun. That's an ugly one. Let's try again. Sure. 5 minus 1i. And then finally, number 6. Again, notice that that is an entirely imaginary number, so that's just -2i. So not a whole lot to say about the rectangular planes here, going back and forth between a quick sketch of that graph and then the number. Keep in mind, this was first semester stuff, talking about those complex numbers and just getting a quick sketch of where they are in that complex plane. What we are about to do is take these and convert them to that polar notation, so then we can do a bit of arithmetic and eventually visualize that symmetry that complex numbers have. So if you're stuck on this, this is a good one. Maybe you want to shoot a quick email or ask a friend. I don't know. But before we move forward from here, we do want to be comfortable with just these quick rectangular sketches because eventually we will use these to help us with polar stuff as well. Stay tuned.